SpaceX has begun reinstalling 3 of the 6 Raptor engines that will power the first orbital-class Starship and repairing the heat shield that will hopefully protect it on its first trip to space. Known as Starship 20 or S-20, the 50-meter or approximately 165 feet tall steel rocket prototype has been stationed at one of SpaceX's 2 suborbital testing pads since August 13th. No testing has been done, though a small army of SpaceX technicians and engineers have instead spent their last 3 or so weeks of effectively turning a collection of steel tanks, tubes, and parts into a functional rocket. While it's unclear why SpaceX chose to do that outfitting work at an unsheltered launch pad, new activity suggests that it may almost be complete. Exactly 1 month ago, SpaceX stacked Starship S-20 on top of Super Heavy Booster 4, or B4, on August 6th, briefly creating the largest rocket in history, and completing a fit test that was admittedly just as much as a photo op. Ship 20 was rapidly destacked and returned to SpaceX's Starbase factory, where all 6 of its Raptor engines were removed. About a week later, Ship 20 returned to the pad and has remained installed on suborbital Pad B ever since. At the time, the implication was that SpaceX had removed Ship 20's engines to allow the prototype to complete cryogenic proof testing with hydraulic thrust simulators. However, despite having carefully modified Pad B over several weeks for that exact purpose, those modifications were rapidly removed before Ship 20's second rollout, precluding a proof test with thrust simulation. The next logical conclusion was that SpaceX would still perform a cryogenic proof test before reinstalling Ship 20's Raptors and moving on to a static fire campaign. Meanwhile, much of the focus of the last few weeks appears to have been on finishing Ship 20's plumbing and avionics wire runs, though it's hard to say exactly what has been done. What is extremely visible and easy to follow is the process of finishing the first orbital-class Starship heat shield and repairing a few hundred broken tiles during its Pathfinder installation. SpaceX has installed 500 to 1,000 plus tiles on flown Starship prototypes like the SN-15, but the company has never come close to the approximately 15,000 needed to cover the entire windward side of the world's largest rocket upper stage. SpaceX has undertaken that process for the first time over the last 6 or so weeks and unsurprisingly seen a number of successes and failures. At some point along the way, a significant fraction of the ceramic dinner plate-sized tiles SpaceX technicians installed chipped, broke, shattered, or ran into other fitment issues. Over the last month or so, a great deal of progress has been made fixing these problems on the tiles, and SpaceX has more or less completed tile installment on the angular aero covers that protect Starship's flap mechanisms, requiring dozens of custom tiles with complex shapes and curves. As of September 6th, Starship's S-20's heat shield appears to be around 95% complete, and the installation of Raptor engines implies that the rocket's plumbing, avionics, and tankage are also nearly finished. For the second time in 5 weeks, SpaceX has rolled Starship's first orbital-class Super Heavy booster from its Starbase factory to the launch pad ahead of a challenging and multifaceted test campaign. A bit less than 2 weeks ago, SpaceX once again installed 29 Raptors on Booster 4. This time around, though, all the engines are believed to be ready for flight, or at a minimum, static fire testing, after completing qualification testing at SpaceX's Central Texas development facilities. Intriguingly, every one of Super Heavy's outer ring of 20 Raptor boost engines is also expected to have its own small umbilical panel that will connect to the orbital's launch pad's ground systems. When Booster 4 was installed on the brand new orbital launch mount, most of those individual engine connectors had yet to be installed, and it's unclear if SpaceX will actually be able to test the complex mechanism before Super Heavy returned to the build site. This time, all 20 engine umbilical actuators have been installed on the launch mount, and it's safe to assume that those mechanisms will be tested extensively in the coming weeks. That testing will be part of a much more involved test campaign. Namely, if SpaceX intends to test Super Heavy Booster 4 at the orbital launch site, any booster testing will simultaneously require the shakedown of the orbital pad's extensive custom-built tank farm and a wide range of other ground infrastructure that simply didn't exist at the start of 2021. Booster 4's qualification is no less daunting, as no Super Heavy booster has ever been fully tested. Now, in the midst of being scrapped and placed at SpaceX's suborbital test facilities, Super Heavy Booster 3 did complete a partial cryogenic proof test and a static fire with 3 Raptor engines. But SpaceX has never fully filled a Super Heavy with almost 3,000 tons or 6.6 million pounds of propellant, and never static fired more than 3 Raptor engines at the same time. Perhaps the most uncertain part of the Super Heavy Booster 4 qualification is its static fire test campaign. However SpaceX gets there, the final challenge will likely be igniting all 29 of B4's Raptor engines, potentially producing a mere 54,000 tons of thrust, thus making Super Heavy the most powerful rocket booster ever tested. Next time on Discover Zen, let's go and discuss, is it possible to terraform Venus? Thank you so much for watching our video. If you liked what you saw, please click that like and subscribe button. Let us know in the comments below if you think all 29 engines will go off without a hitch. Until next time, friends.